Alright, this is our last video in this section, and it's about start plus accumulation method. So this one might seem a little clunky at first, but it actually is faster for certain integrals and for certain functions. It's also, there are some functions you're only ever going to be able to do start plus accumulation. This is just an intro to that, and then you'll see it more as we go. So basically what I'm telling you is that if this is true, we know this is true from the fundamental theorem of calculus. It says that, you know, the integral of some function equals its step-up function. I don't know the actual technical term for that, but the function above it, the value of that function at b minus the value of that function at a. And if we did a little bit of algebra on that, we would see that if we add f of a to both sides, that we actually get this right here. It's all yellow right here. This is the start plus accumulation. And so basically what we're saying is our final value here, this is like the final value of some function. The final value of the function equals the initial value, so this would be like where it started, plus all the accumulation up to that value. So basically what we're saying is, like, we're going to start, say a function has this y value right here, right? We're going to add up all the tiny little bits of change, which is that integral. That's all that accumulation underneath the curve, all those little changes. We're going to add each one of those, and that's going to give us our final value for our function. So we start with initial, we accumulate, and we get to a final. So it's kind of cool that the function value can be found by looking at a starting value and then all those little accumulations. So let's take a look at this. Let's see if we can keep that in frame so we can see it. So if this f prime of x equals 3x squared plus 3 and f of 0 equals 4, find f of 2 without a calculator. So we have two different methods for doing this. The first method is going to be just standard integration. Okay, so we're going to take the integral of 3x squared plus 3, and we're going to go, our initial value is 0 and our final value is 2. So actually we're not going to do a definite integral on that one. We are just going to find the function. So that's dx. What is the function when we integrate this? This is going to be 3x cubed over 3 plus 3x plus c. So that actually equals x cubed plus 3x plus c. That's our actual function. And then the question is, well, what is that function's value at 2? Well, we first have to find c. So when x equals 0, y equals 4. So if I plug 0 into this, I would find that c equals 4. So my actual function value, or function, is x cubed plus 3x plus 4. And now we can evaluate this at 3. So we can say when x equals 3, f of 3, sorry, why did I say 3? It's 2. F of 2, f of 2 equals 8 plus 6 plus 4, so that's 18. So the value of this function at 2 is 18. So this is method number 1. That's the first way of doing it. The next method we're going to use is the start plus accumulation, because we know we can find a function value by finding a starting value and then its accumulation over time. So the first thing we need to do is figure out what everything is, right? What's a, what's b? Well, we know our starting value is a, and that would be this one. This is our initial. Okay, this is our final. And this is going to give us our accumulation. So let's go ahead and write this. We say f of 2 equals f of 0 plus integral of 3x squared plus 3 from, now here's the question, which one goes on top, which one goes on bottom? Well, our final is b, so that's going to match there, so that b is going to be 2, and our initial is going to be 0, because that's our a. And so then we find, I forgot my dx here. Then we're going to go ahead and just evaluate this. Well, we don't know what f of 2 is. That's what we're trying to find. F of 0 is 4. And then the definite integral from 0 to 2 of 3x squared is 3x cubed over 3 plus 3x, evaluated from 0 to 2, which is, let's see, f of 2 equals 4 plus, that would be x cubed plus 3x, evaluated from 0 to 2. So we have f of 2 equals 4 plus, that would be, okay, so this is going to be f of 2 minus f of 0, because that's what we need to remember with the fundamental theorem of calculus, that we take the function at 2 minus the function at 0. So the function at 2 is 8 plus 6. The function at 0 is 0. So we have 8 plus 6 plus 4. So we get the same thing as we got before. F of 2 equals 18. And that might seem a little bit roundabout. It might seem a little more roundabout than the other one, but the reality is it's not, because definite integrals are so quick to calculate. You don't have to do that extra plus c thing. And there are going to be some that this is really the only way. It's the only way to evaluate them, because maybe we have a harder time evaluating the finding the plus c and all that. So that is that one. All right. This one says if an object's velocity is v of t equals 2 to the t, don't freak out, we're doing this with a calculator, because you're all like, what? I don't know how to do 2 to the t. We don't know how to do it yet, but that's okay. We have, we're just going to put this in a calculator. Okay, so if the velocity is v of t is that, and the position at 2 is 8, find the position at 3. So s of 3 is our final. Our initial is s of 2, and our accumulation is 2t dt. And so we're going to go from 2 to 3. And then we just plug, actually let's do some algebra first. S of 3 equals 8 plus, okay, so I don't have the ability to do the calculator and this at the same time. So what we're just going to do is we're going to put in we're going to go to y equals. Actually, no, we're going to go to math. Remember, because the math menu is much more accurate. Let me get big. Okay, so we go to math. We scroll over, we go down to integral. Push enter. We're going to do the integral from 2 to 3 of 2 to the t. Obviously, this is, instead of t, we're putting in x. It's not a big deal. Remember, John found out that we really can only do x on there. Unless we're in like parametric and stuff, which we're not. Okay, so we're going to put that in, and then we push enter. And it finds that that is the definite integral of that. And then all we do is we need to add 8. And our answer is 13.77078016. So our answer here, it's going to be plus 5.770. And so the value of this function at 3 is 13.770. And that is start plus accumulation.